Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to show you how to determine the number of significant figures in numbers that are expressed in scientific notation. So let's get into this. The thing you got to know about scientific notation is that it makes the determining of the number of significant figures really easy, because by putting the measurement into scientific notation, whatever digits are there are automatically significant, because that's the way you use scientific notation. So you put the number in scientific notation, it's automatically assumed that whatever digits there are significant. So, and it gets rid of the zeros and things like that. So you don't have to worry about determining whether a zero is significant or not, because if it's in the digits, if it's among the number of digits in your scientific notation, then it's got to be significant. So let's get into this. So here we have 5 examples. So here I have 7 times 10 to the power of 2. When you're determining the number of significant figures, you're ignoring the 10 to the exponent part, and you're just looking at the first part of the scientific notation. So all we're really interested in are the first part of the scientific notation to the left of the times sign. So we're interested in this number, this number, this number, and this number. So all we need to do is count the number of digits that's given to us. Any digit that's given to us in this first part of the scientific notation are automatically going to be significant. So here we have only one digit, therefore we only have one significant figure. So this is one sig fig, because I only have one digit there. If for B, I have 1, 2, 3, 4. So this has 4 sig figs. So 4 sig figs. If I go to C, again, I only have one digit that's in front of the x 10 to the power. So this is 1 sig fig again. For D, again, I just have the 8 there. So that's going to be 1 sig fig. And here I have 1, 2, 3, 4 digits. So that's 4 sig figs. Let's add a couple more. So if I do F, let's say I have 100. Oops, nope, can't do that. Sorry. It has to be proper scientific notation. Let's say I have 1.0 times 10 to the negative 2. So here I have 2 digits in front of my x to the 10. So I'm looking at this. So all of these digits are significant. So I have 2 sig figs here. Okay. What if I have my next one? Let's say I have 2.0520 times 10 to the negative 27. So again, it doesn't matter. This part doesn't matter as far as sig figs. I don't care about this part. All I care is about whatever this number is and the number of digits. So here, notice that I have to determine the number of sig figs, and I have these zeros in here, and I don't have to really worry about is this zero significant? Is this zero significant? If it's in the number, it is significant, because that's the way that scientific notation is written. So it's written such that all of the digits here are automatically assumed to be significant. So I have 1, 2, 3, 4, 5. So then this one has 5 sig figs. Right? And let's do one more just so I can make clear the point that I'm trying to make. So if I have h, let's say if I'm comparing this to the number 8,000, right? Um, I might have to figure out whether these zeros are significant or not, right? It may not be clear. Is this one sig fig, right? Is it two sig figs, three, four? How many sig figs are here? Now, if there's one sig fig, right? If these zeros are not significant, then I would just have the 8, right? I would just write 8 times 10 to the third, and this would be one sig fig. Or if all of these zeros are significant, then there would be a decimal, and so that would be 4 sig figs. And so I would write in my scientific notation 8.000 times 10 to the third. And so I would have all 4 there, right? But what if only 2 of the zeros, or maybe this zero is significant? How do I determine that? So the scientific notation, I wouldn't be able to, if I write it in standard notation, I wouldn't be able to determine whether or not these all 3 zeros are here are significant, or just 1 or just 2. But scientific notation makes that clear. So if I write it in scientific notation like 8.00 times 10 to the third, right? So it's telling me that only the 8 and the first 2 zeros are significant. So this last zero is not significant in this number. But I wouldn't know that unless I have it in scientific notation, and the scientific notation tells me. So that's why scientific notation is pretty cool, because it automatically tells me how many significant figures I have in my number. Whereas, so this would tell me, oh, I have 3 sig figs, but I wouldn't know that if I wrote it like this. Okay, so that's it for this video. I hope this was helpful. I hope you now know how to determine the number of significant figures in a number that's given to you in scientific notation. If you enjoyed this video, if this helped you in any way, then please, by all means, help me out. Like the video, share the video, hit that like button somewhere over here or over here somewhere. Also, do me a solid. Support my channel. Hit that notification bell. Subscribe to my channel. When you hit that notification bell, make sure that you hit all, so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a comment, please put it down below. If you have a question or a problem you need help with, let me know. If you have a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me, and have a great day.